Hey, welcome back to your favorite Fundamentals of College Math class. We're going to take a look at geometry section, specifically points, lines, planes, and angles. Here's our objectives for this one here. Let's start out with a little bit of vocabulary here to kind of remind you about some of the geometry you've learned. A point, first of all, represented as a small dot. So this small dot has no length, width, or thickness. Now, if we connect two points along the shortest path possible, right? A and B there. We have no thickness, but it just keeps going infinitely in both directions. Right? So that's a line. A flat surface, you might think of like a window or something, right? Except a plane in mathematics has no thickness, though. And there's no boundaries, right? It goes infinitely in all directions. A plane does. It just keeps going. So here's let me give you the visual of these: a line, half line, ray, and line segment here. So we've got the line, which is indicated right there, right? So it's going in both directions through the points A, B. A half line, on the other hand, notice it's got the open hole. An open circle indicates the point's not included there. So it starts just to the right of A. So that's open, and then it goes to the right through B. Array includes A, and it goes through B in that direction. So ray AB starts at A, goes through B, right, in that direction, A to B. And then we got a line segment, right? Line segment AB, or you can say BA on that. Whoops. BA. And it ends, right? It doesn't keep going, no arrows on that. Now, an angle is when you take two rays at the vertex, and the angle is that measurement right there. Okay, so this would be our initial side where we start, and this is our terminal side. Now, in trigonometry, if we rotate it, that's a trigonometric angle. If we rotate it, right? We rotate it, and then how many degrees are there? It is 3 degrees. In geometry, like a fixed angle, like that's like 90 degrees. It's fixed, right? There's no rotation on those. But there's different ways to name these angles. Notice you can say, and usually you'll see it like that, angle one instead of the, that's kind of weird, but you'll see both. Angle one, so you use, if it's labeled inside there with a number or letter or whatever, sometimes you'll see a Greek, like alpha or whatever. Angle B, so you can use the vertex. Just angle B is another way to name that angle inside there. You can use the points on the angle, so angle ABC, angle ABC, or you can go from C to B to A, angle CBA. But your vertex has got to always be, your vertex got to be on the inside of those if you're going to do it that way. So there's 4 different ways to name the angle there. And angles are just measured by the amount of rotation in terms of a trig angle, at least from the initial to the terminal side. So as you guys probably remember, if you rotate all the way around, that's 360 degrees is a full rotation, right? So a 1 degree rotation is just 1/60th, 1/360th of a complete rotation. That's 1 degree. Or if you go a fourth of the way, like if you start here, you just go a fourth of a way around, that'd be a 90 degrees, right? A right angle there, 90 degrees. All right, how about this example here? The hour hand of a clock moves from 12 to 2 o'clock. How many degrees does it move? So it rotated from 12 to 2 o'clock. Well, if it rotates all the way around, right, we know it's going to rotate 12 times from 1 o'clock, 2 o'clock, 3 o'clock, clear around to the 12. That's 12 rotations. So if a full rotation is 360 degrees, and how many rotations have we done? We went to the past the 1, clear to the 2, right? So we went 2/12. We went 2/12 of a full rotation, of a full revolution or rotation. So we're taking a full revolution is 360 degrees, and we're just taking a sixth of that, right? 2/12. Both of those going to 2. And so this ends up being 60 degrees. This is a 60-degree angle in there, right there. 60-degree angle, a sixth of a full rotation. So here's some other angles classified by their degree measurement. If you ever have heard acute angle, you might acute, it's acute, it's a little less than 90 degrees. So any angle that's less than 90 degrees, like 45 degrees, that's an acute angle, or 30 degrees, that's an acute angle. Anything less than 90 is an acute angle. A right angle is when we have perfectly 90 degrees, right angle denoted by that little box right there. Obtuse angle is more than 90 but less than 180. So let's say we rotate, I don't know, 100 degrees, more than 90 but less than 180. That's not very good. It looks more like 140 degrees or something. But anyways, you got to be more than 90 but less than 180. Finally, a straight angle, right? That's 180 degrees. Straight angle, 180 degrees. Protractors is an instrument used to find the degree measure for an angle. So what we do is we place the center of the protractor on the vertex of the angle on the straight side, and then we measure it. So for example, this angle, if you're measuring angle ABC, right here, and we're rotating it, and we're measuring to there, right? And so I'm reading it. I'm going 10, 20. I'm on the inside numbers here, 30, 40. Looks like we rotate 50 degrees on that. I wrote 50, rotated 50 degrees on that. In fact, let's do another one. Let's do it from the other side this time. Let's do from here, and let's rotate. Let me call this, let me go from D. And let's rotate, you know what, let's go to here now through C. So angle D, B, C. Now this time we're going from the left-hand side. So I got to read the numbers on the outside. See how I'm going 10, 20, 30, 40, 90, clear to 130. So that angle right there is 130 degrees. 130 degrees. So if we're starting from the left-hand side, use the outside numbers. If you're starting over here from the right side hand side, you got to use those inside numbers with the protractor. All right, complementary angles. That just means there's two angles and they sum to 90 degrees. Complement. So when you hear complementary, think corner. Complementary corner. And then it asks us, for example, the complement of 70 degrees. So let's say we know this is 70 degrees. If the complement of 70 degrees is what? Well, what's the other angle in here if these two add up to 90? Right, 70 plus what gives you 90? And I said, well, it's got to be 20 degrees. It's got to be 20 degrees. So the complement of 70 degrees is 20 degrees. Right? If you're not sure, then you just say, well, I'm not sure what it is, but I know they got to add up to 90. Subtract 70 from both sides. It looks like it's got to be 20. Supplementary angles, when you hear supplementary, think straight. So 180 degrees. And then it says the supplement of 110 degrees. So let's say we rotate 110 degrees. Here's 110 degrees. And remember, they got to add up to 180 together. So the supplement of 110 degrees, so y plus 110, they got to add up to what? 180 degrees. Subtract 110. What do you get? It's got to be 70, as you probably already noticed, right? So the supplement of 110 degrees is 70 degrees. So complementary, two angles add up to a corner, 90 degrees. Supplementary, straight angle, two angles add up to 180. Okay. All right, let's do some more here. Find the measure of angle DBC with the given information. Measure of angle DBC. So notice they put a little question mark right there. What is that? Well, the information given here is we know this is 62 degrees, but we also know that these are complementary angles. The little square box in there, that means they add up to 90 degrees, right? So X, if I call this X in here, what is this X angle? Plus 62 degrees equals, they add up to 90 degrees. So 28 degrees. Another one here, find the measure of angle ABD. Oh, I'm sorry, the measure of angle ABD is 66, this is the given information, 66 degrees greater than the measure of angle DBC, and they are supplementary angles. So ABD, and DBC are supplementary. So those two add up, right, to 180. And you can see that. It looks like they do. But find the measure of each angle. Well, if angle ABD is 66 more than DBC, so I don't know what DBC is. I know it's, let's call it X. Then this one is 66 more than that. Let's call that X plus 66. So angle, and we know angle DBC and angle ABD are supplementary. So they add up to 180. And angle DBC, we say we don't know what that is, but we know ABD is 66 more than whatever that is. So 66 degrees more than DBC, right? So here's ABD. And these add up to 180 degrees. Well, X plus X is 2X. Subtract 66. And you get 114. So 2X equals 114 degrees divided by 2. X equals 57 degrees, it looks like. So the angle, and that's this one right here, angle DBC must be 57 degrees. And since angle ABD is that one plus 66, right? So we got 57 plus 66. Well, 57 plus 66 gives you 123. That's angle ABD. 123. All right, vertical angles now. So vertical angles, that's when two lines intersect, they're going to create opposite angles, and those are what we call the vertical angles. So these opposite or vertical angles are equal. So for example, this 68 degree and that angle 1, we know they got to be the same. They got to be the same. And then this one on top, angle 2, I did in blue, and angle 3 are the same. Angle 2 and angle 3 are the same. Now, how are we going to find those angles? Well, if you look at this, can you see how these two are on a straight angle? So angle 2 plus that 68 degrees, those are on a straight angle. So those add up to 180 degrees. And so you can just do the math there, and you get 112 degrees. So angle 2 equals 112. So if angle 2 is 112 degrees, well, angle 3's got to also be 112 degrees. Found angle 1. Right, so because angle 2 and angle 3, they're opposite angles, they're vertical angles. All right, some more line relationships here. Parallel lines. So parallel lines is when, and you'll see them a lot of the times denoted. If that's got two arrows, that's got two arrows. That means they're parallel, right? Or maybe there's one arrow on each one. That means they're parallel. Okay. And that means they're never going to intersect, right? If they keep going in both directions, they'll never hit each other. Never have a single point in common. This is your transversal that just cuts through those. That's just called, referred to as a transversal line. And then we've got these, so if you have two parallel lines and you have a transversal, okay, alternate interior angles are going to be equal. Okay, so this one and this one, those will be equal. Okay, and so will, so notice they're alternate, meaning on the opposite sides of the transversal, alternate sides, but they're on the interior. They're on the interior part of it, right? So two more alternate interior angles would be right here. So that one and that one. Again, these would be equal. Alternate interior angles. All right, let's do alternate exterior angles. Alternate exterior angles. In fact, if you look at this, by vertical angles, these two are the same. Those two are the same, right? Because they're on opposites. Which means this one and that one would be the same, right? So if you've got two parallel lines, those are called alternate exterior angles. Alternate exterior, they're on the exterior of those parallel lines and on the outside. Alternate exterior angles are the same. Here's the other two, alternate exterior, I'll do it with two. Those are also the same. And finally, you've got these corresponding angles. So that one and that one are parallel, are equal, congruent, have the same measure. This one and this one, same measure. This one, same measure, and so on. So if they're on the bottom right of each of those the same. 1, 2, 3, 4, 1, 2, 3, 4, and so on. Did I miss any? So those are all referred to as corresponding. Okay. All right, let's do an example here. Find the measure of all angles. So they give us angle 8 right here. They say this is 35 degrees. So I'm going to start out with my vertical angles. I'm going to say, well, if that's 35 degrees, I know angle 1 has got to be 35 degrees. Why? By vertical angles. Now, let me keep going with that. Let's use what we just talked about since we have these parallel lines with the transversal. Let's do the corresponding angle to angle 8. So if this is 35 degrees, that's 35 degrees. Angle 5 is 35 degrees. It's called corresponding angles. Let's do alternate interior angles to angle 8. So if angle 8 is 35, angle 2 is 35 degrees. Alternate interior angles. So angle 8 and angle 2 are alternate interior angles. Now, how are we going to find some of these other ones here? So like angle 7. If you look at these two, hey, those are on a straight angle. So angle 8 and angle 7 have to add up to 180 degrees. And we know angle 8 is 35 degrees. So we subtract 35 degrees, and we get 145 degrees. So that angle 7 is 145 degrees. Angle 7, 145 degrees. Why? Straight angle. Now let's do, let me change my color here. If this is 145 degrees right here, this angle 7, by alternate interior angles, angle 7 and angle 3 are the same. So alternate interior angles. Let's do the vertical angle. Angle 7 and angle 6 are the same. Vertical angles. And angle 6 and angle 4. Angle 6 and angle 4 would be the same. That's alternate exterior angles. Exterior angles. It looks like we found them all. Well, that's points, lines, and planes. Thanks for listening. We'll see you guys next time.